Hi, this is Joe from the Math Perimeter. In this video, we will use L'Hopital's rule to evaluate the limit as x approaches infinity of ln of x all over x and the limit as x approaches 0 plus of x to the x. We begin by evaluating the limit as x approaches infinity of ln of x over x. To begin, we apply L'Hopital's rule. This gives the limit as x approaches infinity of ln of x prime all over x prime. Taking the derivatives gives the limit as x approaches infinity of 1 over x over 1. Simplifying gives the limit as x approaches infinity of 1 over x. As x grows large, the denominator grows large while remaining positive. Hence, our overall function grows smaller and remains positive as x grows large. Hence, our final limit is 0. Next, we evaluate the limit as x approaches 0 plus of x to the x. To begin, we use exponential properties to obtain the limit as x approaches 0 plus of e to the ln of x to the x. Using logarithmic properties then gives the limit as x approaches 0 plus of e to the x ln of x. Using limit properties then gives e to the limit as x approaches 0 plus of x ln of x. Using negative exponents, this is e to the limit as x approaches 0 plus of ln of x over x to the negative 1. Applying L'Hopital's rule, we obtain e to the limit as x approaches 0 plus of ln of x prime over x to the negative 1 prime. Taking the derivatives, we get e to the limit as x approaches 0 plus of 1 over x all over minus x to the negative 2. Multiplying the numerator and denominator by negative x squared, we obtain e to the limit as x approaches 0 plus of 1 over x times negative x squared all over negative x to the negative 2 times negative x squared. Simplifying gives e to the limit as x approaches 0 plus of minus x over 1. Dividing, we obtain e to the limit as x approaches 0 plus of negative x. Applying the constant multiple rule then gives e to the minus the limit as x approaches 0 plus of x. Taking the limit gives e to the minus 0. Multiplying, we obtain e to the 0. Simplifying, we arrive at a final answer of 1. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.